everything doesn't have to be bunch of talks. I hope you're able to gain from today's stuff.
Yeah. So in the next 30 minutes, we'll be talking about Prometheus and the MLOps lifecycle. We want to talk about a bit about things that have worked for us using Prometheus. Both of us have been working closely with machine learning, things that have worked for us, and that's what some of the things we talk about monitoring, especially in the context of machine learning. So I'm Rishit, I'm a student at the University of Toronto.
And hi, I'm Shoy, I'm a contributor and maintainer at Lifecycle, which is the Switch community.
Okay, so when we are talking about monitoring, the traditional software monitoring, a lot of you might know about monitoring in software, or you might have done it a lot earlier using Prometheus or maybe some other tool. But if you don't, usually monitoring in the context of software includes that you think about SLOs, monitor if your SLOs are being met, monitor system failures, and so on. There's a lot of things that monitoring means.
And if we talk in the perspective of machine learning, right, because today's talk is all about MLOps. So if you take a look at this diagram for the MLOps or the machine learning life cycle, there are of course multiple steps, right, from getting your input data and cleaning it up, and then using that data to train your machine learning model, and going ahead and evaluating your model, testing the model, and then finally productionizing it. And post the productionizing of the model, you are also looking at you always test your model from time to time to ensure that the model performance does not degrade as the model is being used in production. And post deployment, you're also continuously monitoring the model. And all of these are steps that are part of the MLOps lifecycle, and that's where specifically when it comes to the monitoring and observability side of things, we'll see how Prometheus plays a very key role.
So we want to talk about monitoring in the context of ML. Sure, would you like to talk a bit about that?
Sure. So if we take a look at the most important use cases, as I mentioned, that once you productionize your model, there are a lot of hidden variables that might crop up, because when you're working with the production data, there might be cases where you might run into edge cases where the model does not perform. Then over time, there's also a possibility that the data distribution on the basis of which originally a model was trained on, that might shift. And we basically will be explaining two different ways in terms of the time and in terms of the data drift. So we have particularly two terms that if you are in the ML ecosystem, concept drift and data drift are a couple of ideas that you'll come across from time to time. And there could be a situation where a model might not be configured properly. So the idea is that model will still make a prediction, but of course it's not always going to be making a good prediction. That's what we're also trying to monitor from time to time, that the prediction does not go, like the prediction rate does not go down.
So two things I particularly want to mention is the aspect of different challenges. The monitoring in context of machine learning and what we want is pretty different from how you might have been using Prometheus earlier. So these are the different challenges I particularly want to highlight on, and so the ideas are a bit different here. What we want to achieve is a bit different than traditional software, and I also want to highlight that the system goes through properly. There is no error as such. You don't have any system failure, you don't have any SLO failure, nothing at all. The model still makes a prediction, but you're still doing something wrong. It could be you are still doing something wrong. The model does not make sensible predictions. So this is also a very interesting use case. Everything works perfectly, there is no error. But you still need to be able to monitor in those situations. So the ideas are a bit different here in context to software. So what we want to do is not just monitor system metrics and resource metrics, which we already do. We introduce a third term over here called model metrics, which is trying to figure out all of this. The model is still giving you predictions. There is no error, but you have to figure out something, make monitoring work just by getting the model metrics. So that is what we want to do. And in this presentation also we particularly be stressing on model metrics part, because system metrics, resource metrics, you might have been doing that since a long time, or some other talks even before us. Do cover this. So we want to talk more about the context of ML. So we have more in this presentation. We'll talk about monitoring model metrics. So two of the main things we want to monitor, and I just to give set you context or give you an example of why you might still want to monitor if your system works well, there is no error. So it could happen that environment changes affect the model. So for example, there could just be a different environment from when you had created a model, and now when you are deploying the model, the environmental variables are all different. In that case, your model works well. Your model works, but it does not work as you expected it to be. It does not give you the right predictions. There could also be a change in data distribution. So the idea of the thing we want to do with Prometheus in the MLOps lifecycle is have a model trained on some data and then apply it and then make predictions from it. Now a lot of you might tell me that's not exactly what we want to do. That's a very simplified way of saying it. You would also iterate your model and do all that. But let's just stick with the simplified definition for right now. And one thing that would majorly go wrong and still have your model work, but we want to get that edge case in our monitoring aspect, is that the data distribution on which you trained your model is different from the data distribution on which your model is working. So think of it as the data on which your model is making predictions should be in the same distribution, or it should be in the same likelihood of distribution as your original data. And there are multiple mathematical models to measure this, multiple ways you can do this, and we'll not go into the machine learning specific aspects in this talk, but these are the two ways very popularly known as concept drift and data drift. So we also want to monitor these. We think of them as edge cases. We still want to monitor all of this. So can you talk a bit about how Prometheus comes into play?
Sure. So this is where we were talking about Prometheus. So far what we saw was that the system metrics are something that probably was already covered in some of the earlier talks, and some of you who might be Prometheus users might be already doing that. So this is a quick sample of how you could potentially use Prometheus, because it's one of the most promising tools to be able to monitor your model performance and also the model health. So you can use a combination of both Prometheus and Grafana, and that's what we will be showing in today's demo as well. So primarily what we are doing is that Prometheus will allow you to scrape your data. So even if you are having a time series database or time series data, that's what you will be able to capture with the help of Prometheus. And then you'll be able to see the Prometheus logs. And using that, at least you'll be able to see how does the model performance vary over time. And that will give you some insights to understand whether the performance of the model is actually degrading over time as you kind of analyze these logs that you get from Prometheus. And of course, over that you can put in some alerts with PagerDuty or email, and then we can also go ahead and view them on a Grafana dashboard that we'll be also covering in today's demonstration. So it makes it easy for, as a data scientist or as an MLOps engineer, to integrate Prometheus to see how the model performance works over time, especially because we might have some edge cases that might not be considered when deploying the model initially. So as part of the model serving process, it plays a really important hand in determining how and what changes will you be making inside of your model post going into production.
Great. So next up, we'll actually, let's go one slide back. And next up, we'll actually take a look at two demos, and we'll get more context for these demos. So we'll try to show how do you do this different kind of monitoring, or monitoring in a different context, like we talked about, monitor all the aspects that we talked about. So Shiva, would you like to start out with a demo of showing Prometheus on Selenium?
Sure. Alright. So this quick introduction about Selden itself. So Selden is one of the tools provided to you. It's an open source tool specifically for model serving, model performance, model monitoring, model deployment. So it works very closely with Kubeflow. So you can definitely check it out. But what we're going to be covering is the demonstration for how you can use Prometheus. So it's going to be a little difficult for me to stretch to go to the screen. Let me actually try to monitor and try to square and mirror my screen. So what we're going to be covering is an example for being able to view the Prometheus metrics with the help of Selden. So some of the prerequisites that you require in case you also want to use Selden is that you have to install the Selden code. So for that you need probably a Kubernetes cluster. You can use Kind if you're running it locally, or you can also use services like Civo or GT or any other cloud provider to just have a Kubernetes cluster running. So in my case, and I'll just open up my terminal as well. So in my case, I have, let me just quickly show you my kubeconfig. So let's go to my.kube. Right. So if you're able to see that right now I'm running my Kubernetes cluster, it's a GT cluster, so it's running on Google Cloud. And what I've done is that I've already configured my, and I'll just quickly show you my Kubectl pods as well. So let me just go ahead and do that.
While he does that, what's the right way to say kubectl? Anyone wants to go first? I say it as kubectl. If you say it another way, please don't hate me or hate Shiva. Go on, Shiva.
Yeah. So as you can see that currently I have a number of different services that are pre-configured in my Kubectl. I hope that everyone is able to see the screen, right?
Yep.
Yeah. So you can see that I have, of course, Istio, because Istio gateway is used for monitoring and kind of like looking at all the traffic that is going on. So we have an Istio gateway, and apart from that, we have a bunch of Selden related, pods that are running. So we have the core Selden, and then we have a few monitoring ones as well. So these are essentially what is running. So we have a Selden Prometheus operator. So if you want to go ahead and run any particular command and run any machine learning model, you can use the Prometheus operator that works on top of Selden to monitor all your requests, and you're able to see that in your dashboard. So since I already have my monitoring running, you can see that this is my dashboard, Prometheus dashboard, and over here, so far I've just run a few sample requests. So the idea is that if you follow along this documentation, and we'll share the link for this documentation, first we're just setting up Selden code, and then we install the Prometheus operator and we set it up with Selden. And once we basically do that, then what we're going ahead and doing is that we're just deploying this example model that you can see. It's just a simple model that echoes, and you can kind of then see the results as we will run this. And as you go ahead and check this particular docs out, you'll see that how, as you let's say from time to time you run your machine learning model, you'll see the changes coming in this live time series data. So over here, I already have one of my windows open, and I have a pull request that is heading to my endpoint, which is running on localhost 8003. So I've used code forwarding to kind of run it locally, and you'll be able to see it in that GT cluster as well. So as I run this, you see that it ran it successfully. And now let's take a look at our Prometheus dashboard. So let me refresh this. So as you can see that we have now a new request that has come up as compared to the last time. So we were up to 12 requests, and now we have 14 requests. So this way, what you can do is that, of course, since we are using, you can put in any query into your Prometheus dashboard to and then also monitor to get a summary version. In this case, what I'm doing is that I'm looking at on a per second request basis that how is my model working, right? So how many requests have been sent so far. But you can also create your custom dashboards as well to kind of monitor the actual live prediction rates that are going on for a particular model. In this case, the example that we showed is a simple model, but you can run it on any model that you would want. sklearn, TensorFlow, PyTorch based models, and this we can monitor your live machine learning performance on the Prometheus dashboard. And you can further expand this by also going ahead and creating a Grafana dashboard to kind of monitor your logs. That will be